Alrighty, happy Monday. You all made it? Got through the weekend? So this is week 3, believe it or not. I don't know if you like percentages or not, but we're at the end of this week, we'll be 20% of the way done. It's kind of crazy already. Like it's going pretty quick. So we're going to talk about branches, chapter 3 today. We won't get through all of it. We'll get through a lot of it, and then later today we'll have our very first lab. I'm very excited. So we'll meet over in HPEC 1190. It is that way. Sometimes it's just called the EC. I don't know why sometimes they add the HP because it's named after the guy. But it's third room on the left, right by the Engineering Success Center, which is cool. There's some info about tutoring I've got for you. I'll send over to you. So the lab idea is I give you an assignment and then we work on it. I don't really do a whole lot of talking, but I can walk around the room and help you with it. So I'll show you what we go through. So I'll probably spend the first 5 minutes or so showing you all the GitHub stuff one more time, and then you'll go and try that and then do the lab exercise. It goes pretty well. For labs, I love if you folks just buddy up with the person next to you, or 3 people, in a row, or 4 people, however many, makes a lot of sense, and work together. That's perfectly fine. That works well for a lot of people. I'm still happy to go around and answer questions too, but you can work with your partner on it. Now, working with doesn't mean, okay, you do this part, I do this part, and we send each other it when we're done. Right? That's not good. But talking, collaborating, working together, helping each other, that's perfectly fine for labs. That's a great way to get through something, to learn stuff, and goes pretty well. All right, so we'll do that. Project 0, hopefully you had a chance to look at. If you didn't get started on it too much, that's okay. Not too big of a deal. But definitely want to start earlier rather than later. Once we've talked about some stuff today, you'll have everything you need to finish it out. Right? You could get most of it done last week. We'll talk about branches today, and you can get it all done. That's due on 9/20 when class starts. Because my idea is I'll go over the solution to it. So I'll show you how I would solve it, and it's okay if it's different from how you solved it. It's okay. There's lots of different ways to solve problems with code, which is one of the fun things. It's very creative. Everyone can approach it a little bit differently. Now, later on, you'll learn a little bit more of the sciencey part of things. We don't really even get into that because that's okay. You got to get some more experience under your belt. And you could argue this is more efficient and makes a better solution. And that's a perfectly fine argument. Like you're welcome to say this is better because it's more efficient. That's pretty fair. But for everything we're doing in this class, as long as it gets the job done, I don't care if it's an ugly mess. A lot of people say, oh, my code is ugly, and that's fine. You're just learning. Right? You don't feel like you've got to write perfectly beautiful, amazing code. It's okay if it's inefficient. It's okay if you have a bunch of variables. It's no big deal. You don't have to optimize anything. You'll get to that later in the process. Right now, what we're really learning how to do is solve problems. And how to solve problems and then translate that into code that we can read, right? You want to be able to read it. You want me to be able to read it so I can evaluate it. And then later on, you want someone else in the world to be able to read it too. And then you need C++ to be able to understand it as well. It's sort of incidental that C++ needs to be able to understand it because the code's really there for people. That's why we write it in English. If we didn't care if people could read it, we would still be using punch cards, right? Because the machine can figure those out. I have no idea how to read those suckers. My dad has a big stack of them in his garage because he's sentimental about it. I don't think he could even take them anywhere to run them anymore. But he's like, no, they're so cool. I remember doing this in school. I was like, okay, Dad, that's cool. I think it's interesting, but they're meaningless. The idea that we have code is so that we can go and read it. We can understand what's happening. We can follow that logical thought process of, okay, I've got some variables. I'm doing some arithmetic. I'm getting some results. I'm getting some inputs here. I'm doing some transformations. Something interesting is happening, right? If you think back to physics, I don't know, did anyone have in intro to physics class? I was kind of blown away when I learned if you push against a wall, you're not actually doing any work, right? Because nothing's moving, nothing's changing, right? So if your program doesn't accomplish something, you didn't really do anything, right? If it spits out the exact same answer every single time, it didn't really do any work. It's not an interesting program, right? No one's going to sit there and run your program because it's always going to give you the same number every time. Right? You want your programs to solve problems. And for now, our problems are really dumb and really basic, and that's okay. But eventually we'll get to more interesting problems that we can solve with our programs, right? Okay, so let me jump into some code here. So I'm gonna start up Visual Studio. I'm gonna make a new project, because I think I called everything chapter 1 last week. That was my bad, I forgot to make a new project. I'll try and organize these things by chapter. I know it gets to be a little long. When I hit run, I have to go through a bunch of different prompts, but that way you don't have to look a lot of different places for that code. Oh, I called it all chapter 2. That's good. That's good. All right, so I'm going to make a new project. So the steps that I'm skipping now is I've already cloned my GitHub repository. We'll talk more about that in lab, because every lab you'll have a different repository, which just means folder. You'll just have a different folder to put it in. Right? In every project you'll have a different folder, just a folder to put it in. Right? So that step of cloning the repository is getting the copy of what's out in the cloud and matching it in your computer. When it starts, it's empty. Not very interesting, and that's okay. Right? We'll put code in it, and then we'll commit and push to synchronize all the things we did and say, hey, cloud, I did some stuff. And we'll go sync with the cloud. And once it's out in the cloud, you can see it and I can see it, and everyone's happy. Right? So I don't need to clone the repository again, because I already have it. Right? It's my users, documents, GitHub, CIS 150, fall. So it'll say CIS 150, fall 2023, and then the assignment name, and then your username. Just follow a convention, because I think naming conventions are nice and easy. And I'll just make a new project in that folder. So when I do my new project, I just want an empty C++ project. It says, where do you want to put it? Right? I just want to make sure it's in that repository folder. It's just a folder, right? And then we'll just call this one chapter 3. Again, you might call it lab 1, or lab 2, or project 1, or project 2. You can put anything you want in there, really. If you want to start putting other code in repositories, go for it. I don't care if you use those. You can make your own private repositories. It's not too big of a deal. And then this checkbox, a solution can hold multiple projects. We're not going to get there. So it doesn't really matter. So if you check the box, great. If you don't check the box, great. You just get an extra folder or not. It's not going to hurt anything. I usually don't check the box, because usually I'd like to have a solution folder and then I have a folder for every project. It's just what I like. It's no big deal. It's not going to hurt anything one way or the other. Just a way to organize stuff. We'll say create. So now back in GitHub, if I go look at my repository, it's going to say, hey, there's some new stuff here. Right? Because Git's job is to watch this folder for stuff to change. So Git will say, hey, I saw something new. So I'm going to make sure I'm in the right repository. I see the SLN file, that's the solution file. The solution defines all the projects and different settings for Visual Studio. They're mostly garbage, right? We don't care too much. That's fine. The VCX that's a project file. Great. So this is a C++ project file. Great. And then some project filters. Great. These things, no biggie. We don't care. They're just going to be there. Okay. Well, there's no code yet, because we didn't add any code. So in the empty project, because we told C++ we wanted an empty project, I'm going to come over to the right here to my source files, right click that and say, hey, I want to add a new item. So, okay, what do you want to add? And we'll call this chapter 3.cpp, and CPP for C++. Right? It's just a convention. You can really call them anything. Visual Studio can probably figure it out, but you don't need to change it. Right? It's fine to be a CPP file. We'll go add that, and now in GitHub it should say, hey, there's a CPP file. It's empty right now. There's nothing in it. So I can make a commit. Right? The commit is just a snapshot. Git takes a picture and says, this is what this folder looks like at this point in time, because it can track changes to things as we go. So I'll just make a commit now and say chapter 3 started. Remember, commits are free, or essentially free. We don't have to pay for that electricity, thankfully. And then I'm going to push to go synchronize what I did with the cloud. But once you make a change locally, once you commit it, once you make that snapshot, the cloud doesn't have it yet. You have to go push it out to the cloud. Great. So now I've got it. So if I wanted to, I could say view on GitHub, and it'll take me out to the website, and I can go navigate around. Right? You can click into folders again, go find your CPP file. Again, it's empty, nothing in here yet. But this will be the file here, and it gives you a URL right to the file. It's fantastic. So you can take this URL and send it to me if you're having problems. Right? So now we can start writing some code. So we have to add a bunch of stuff here. And this is really boring. It's okay. So we're going to include the IO stream. We're going to have using namespace standard, and then we have int main, set of parentheses, set of curly braces. Eventually we should return a 0, and everything goes inside of main for now. Eventually we'll get to other things. Right? But for now, put a couple lines in. You please don't have to memorize it. I've typed it way too many times. It's stuck in my head. You can just go copy paste it if you want. It's not a lot to memorize, but that's okay. And because we're going to use strings, we'll probably include string as well. Right, if we're dealing with user input as strings, a lot of times we'll include string. So that way we can do something interesting with the strings that we have. Okay? So in our previous example, stuff got entered, we did some arithmetic, we spit some answers out. And if it followed that flow, I could give it different inputs and I'd get different outputs. But there wasn't a lot of differences that would happen. Right? Every time I would kind of do the exact same thing. So like today, it's kind of a nice day, but if you're thinking, hey, do I need to bring an umbrella or not? Because I think last week we got rained on, right? So what's the kind of thought process we go through in our heads? We say, well, if it's going to rain, I should bring an umbrella. Right? Is that kind of what happens in English? Yeah. Yeah, exactly. Yeah. So in our heads in English, we say, okay, if something happens, then I need to do something. Right? Turns out we can do the exact same thing in C++. So we can see if it's going to rain, we should do something. Now, lots of different ways to go about it here. When we want to compare inputs, when you ask the user to enter just any sort of text, it gets to be a little messy because who knows what they're going to type in, right? People will type in the weirdest things. So something I'm fond of is using numbers for inputs. So I'm going to see out a couple things. I'll say, hey, enter a value for the weather today. And then we'll kind of build out a little menu here. So I'm going to say, okay, 1 is for sunny. Sunny and hot. And more end lines. And then how about we do a 2 and a 3? How about cloudy, cloudly? Oh my goodness, cloudy. And how about mild? It's not quite fall yet, so I don't think we're getting cold yet. And then we have rainy. Right? But we should change those numbers, 2 and 3. So what I'm expecting the user to enter is a 1, 2, or 3. Right? Again, users will do whatever the users are going to do, but we're going to give them as much as we can to try and get good input. Eventually, we'll figure out how we can handle bad input. We're just not there yet. So if you don't enter a 1, 2, or 3, we're in trouble. But that's okay. No big deal. So now I'm going to tell C++, hey, I need a place to store their, the weather input. Sure. We have a place to store, right? We expect it to be an integer. Here, that's their weather input. And then we can see in the weather input. Oops, and a semicolon. There we go. Okay. So now I can tell C++ to do something specific based on what the weather is. Right? So I can say, hey, if the weather input, there it goes. Now, to compare values, we said, hey, if it's a 1, well, I can't just say equals 1 here because remember, this single equal sign is for assigning values. That's the assignment operator. If you want to check does a value equal something, you use 2 equal signs. And it's going to warn you here that assignment used when equality probably intended. We get this nice little warning here. It's really small, I'm sorry. But the compiler is trying to tell us, hey, you probably don't actually want to make weather input equal 1. You probably want to check does it equal 1? Right? It's a slight difference here, but it makes all the difference in the world. So say, okay, if the weather input is equal to 1, well, then I should do something. Now, there's a couple schools of thought here. I am very fond of curly braces. Curly braces tell C++ that everything inside this set of curly braces should run if this is true. Technically, if you only have a single line here, you don't need the curly braces. I'm going to tell you just always use the curly braces. It's just a good habit to get into. Now, other places and other companies have different styles and conventions, and some of them will say skip it. I'm going to tell you, as a new learner, always use the curly braces. It will save you so much time, hassle, energy, and effort. And you're all probably too young, but years and years and years ago, so it's maybe when I was in school, the Safari browser in the legendary Mac that's unhackable and all sorts of BS sort of things here, but no one really used them, so no one cared to hack them back then. But Safari had an issue that something could happen maliciously that would cause your encrypted web traffic to no longer be encrypted, which is sort of a big deal, right? We sort of rely on being able to get to websites securely and have encrypted connections to websites for all the things that we do. And that happened because the developer didn't use curly braces. So That's your warning story. Just always use them. Okay. If someone tells you later in the future not to, and you have style guidelines, sure, just smile and nod. It's okay. They sign your paycheck. No big deal. But I'm going to say always use the curly braces. So if the weather input is equal to 1, then we want to see out, I don't know what, bring some sunscreen. Because it's hot and sunny, right? Sunny and hot. Don't forget your sunscreen. Sure. No, I'm not getting paid by big sunscreen. No payments out there. And honestly, I try to avoid sunscreen myself, but that's another story. Let's not go down that rabbit hole. All right, so if the weather input is 1, we'll say bring some sunscreen, and then what else should we say? Drink lots of water. Right? You can have multiple lines of code. Now, the code inside of a set of curly braces is commonly known as a code block, a block of code. Right? So everything from the start curly brace to the end curly brace will run if this is true. Now, if it's not true, C++ just completely skips it. It says, if this is not true, right, I'm going to ignore this code block. You told me only do this if this is true. Okay? So what we can do then, if we want something else to happen, if it's not true, right, we just say else, and we give it another set of curly braces. So if it's not 1, we can have an else. See out. What should we tell them if it's not sunny, not hot and sunny? Say goodbye to summer. I know it's sad, right? We got 10 more days, right, till the start of fall, officially. I'm sure it feels like summer still to you all, right? That's how seasons work. I don't know. I can't believe how dark it is. It's dark so early, which is so sad. But there's a lot of mosquitoes, so we don't want to be at the playground anyway. All right, so say goodbye to summer, sure. Now let's give it a try. So anything other than a 1, I should get say goodbye to summer. If I enter 1, I should get bring some sunscreen. All right, what do we want to try? 1, all right. Bring some sunscreen, drink lots of water. Very exciting program. But now if I don't enter a 1, let's say 2, say goodbye to summer. Cool, that seemed to work. How about a 3? Say goodbye to summer, all right? How about I enter hot? Say goodbye to summer. Huh? I didn't enter, well, it wasn't a 1, 2, or 3. So I guess it was not a 1. That's true. Weird stuff happens, right? If we're dealing with inputs, because users will give you weird stuff. Again, just be aware, okay? So for now, we're going to assume they're probably going to give us the right thing. Now, we gave them 3 choices, though. A 1, a 2, or a 3. So we probably don't want to just say, okay, if it's 1 or if it's not 1. Not really what we wanted here, right? So we could say, okay, else, and then we can add another if here. Hi, do you need something?
Is this CIS 150 class?
Yeah.
I'm doing it slowly.
Oh, welcome. Come take a seat. Have fun. All right. So if we want to check for a different value, we just add another if. We can say, okay, if it's not a 1, else if my weather input is equal to a 2. And again, this is sort of how we would think of it in English, right? Okay, is it a 1? No. Okay, is it a 2? No. Okay, is it a 3? No. Okay, is it a 4? And as many menu options as we want to have here. It's like those annoying phone trees. Press 1 for this, press 2 for this, press 3 for this, press 4 for this, press 9 to repeat the menu. You're like, I just sat through this whole thing. Like, okay, phone trees are obnoxious. So we can say, okay, if it's a 2, then let's go do something. So 2 was cloudy and mild. We can probably leave that as say goodbye to summer. And then we can now say else. So logically, if it's not a 1 and it's not a 2, they probably entered a 3. Probably. I mean, maybe they gave me something else crazy. So either way we want to do it here is going to be okay. So if you want to be very specific, we can say, okay, then let's check, does weather input equal a 3? And then we'll tell them bring an umbrella. Bring your umbrella. Right? So if they don't give me a 1, they don't give me a 2, they don't give me a 3, well, now we could even tell them here, like, see out, I don't understand. Said enter 1, 2, or 3. Sure. Uh-oh, I've built errors. I forgot my semicolons, right? Expected a semicolon. This is a very helpful error. Right? That was pretty nice. Usually you get a red line. There's the red line. So the red line is down at the curly brace line. I could put the semicolon here. Remember, C++ is okay with this. Don't do this, right? Don't just put weird semicolons places. So it'll do it for you, like if you hover over where that red line was, it's suggesting things, and like you can say, okay, add an end. Oh, and it put it in the right place. It figured it out that time. Sometimes it puts it in really weird spots, so it tries to give you some suggestions. Okay. Now you'll notice every time I have a code block, stuff has been tabbed in one. That's the visual cue to us that the code belongs to the block above. It's just a visual cue, right? C++ doesn't care, right? You can have stuff all over the place. You can it can all be flat. I think just looking at this though is a little bit harder on your eyes. I know you're all new to it, you haven't done it all at all before, so maybe it's all hard on your eyes, but looking at this is really awkward compared to stuff that's nicely indented, right? You can say, okay, this code belongs there, this code belongs there, this code belongs, this code belongs. It just gives you that visual cue that it belongs to the code block above. That happens automatically in Visual Studio, right? If you don't have it happen automatically, you can always go to Edit and Advanced, and you can do Format Document, and it will go reformat things for you. People stress about the tabs all the time, and like they over tab or they under tab or things are in weird places, and it's no big deal. Just go Edit, Format Document, and it puts most things back for you, right? Not all the time, but most things it puts back for you. Like now I've got this weird set of curly braces here. That's no good. I don't know how I did that. But most of the time we'll fix it. All right, anyway, we're going to try it again. So let's try a 1, let's try a 2, let's try a 3, and we'll try something other than 1, 2, or 3. The 1 is sunscreen with water, looks good. 2 is say goodbye to summer, because it's cold and mild, or cloudy and mild. And 3, bring your umbrella. Great. And then let's try hot. I don't understand. I said enter 1, 2, or 3. I like when the computer is a little bit snarky. It amuses me. And some people think that's not very professional input and output, and you might get upset if the computer gets snarky with you. I think we all understand that computers don't actually have emotions, and that it's not getting snarky with us. It's just someone told it to because they're a funny person, right? So someone has a really interesting iteration of the Chat GPT that there's prompts you can give it to like be insulting. Like there's that restaurant you can go to where everyone insults you at the restaurant. Seems very weird that we enjoy that experience, but it's so different and out of the normal that it's something you can appreciate. I don't think people go there every day, so I think you get tired of it, but it's novel and interesting. So if you want to be snarky, go for it. Right? I don't care. Right? I'm not grading you on is your input and output professional. Right? Have fun with it, because that's the fun part, when you get to have some fun with it. All right. So if it's a 1, else if. It's a 2, else if it's a 3, and you can just put as many of these else ifs, else ifs, else ifs, else ifs, else ifs together as you want. Right? It's a chain of them. Right? Because I'm saying, okay, did you enter this, or did you enter this, or did you enter this, or this, or many things as we want to check is perfectly fine. As long as they are chained together, they are mutually exclusive. One and only one of these can happen. And I think that makes sense because your input is either a 1 or a 2 or a 3. Like your input can't be more than one of those things, right? So only one of those will happen because only one of them fits. Does that follow? Now, what gets weird is you don't have to do exact matching every time, right? So another sort of input we could have here, let's say cout, enter your percentage grade like 0 to 100. Now, I always like giving the user expected inputs to tell them, hey, enter it like this, or like, hey, give me a 1, 2, or 3, because I don't know, if you say enter your grade, people might give you A, B, C, or D, or E. And our program won't be able to work with that because we didn't expect that. So again, tell them what you want and you're more likely to get good results. It's not perfect, but you're more likely. So if we want to do some arithmetic here, we have other options rather than just matching, right? We don't want to say, okay, if it's 100, A, if it's 99, A, if it's 98, A, if it's 97, A, if it's 96, A. I think you're all thinking that's terrible, right? And Eric's out of his mind. There's got to be a better way. Yes, there is. So we can say, okay, hey, if my, we got to input it here, don't we? So we should have, maybe this is a double, because sometimes you have percentage decimal places, right? Come on now. So we'll have a double for score, and then we can see in the score. Score. Okay. I say, hey, if my score, and now because C++ knows how to do math, we have access to the full range of relational operators. You probably never called them that in math class, but greater than or less than, or those are relational operators, right? How do I relate to this? Am I greater than? Am I less than? Am I equal to? Sure. So we'll say, hey, if you're greater than or equal to, right? And you can just say greater than, or you can say greater than or equal to. Either one's perfectly fine, right? Depending on what fits your situation here. I think we had 93 is an A. Is it 94? It might be 94. Does it matter? Do I need to go look? I feel like I have to go look. I'm sorry. Let me just go double check. 94. Yeah, 94. Okay. So greater than or equal to 94. Fantastic. Now, I round things because I think decimal places are stupid when it comes to scores, right? So if I just tell the gradebook to ignore them, actually the gradebook rounds for me, and then I don't even have to admit to rounding because people give me dirty looks sometimes. They're like, 93.5 should have been an A minus. Why? That's stupid. So we can do that. We can say 93.5. We can get very specific here, right? Go for it. Because we're writing the code. We can have decimal places. So we can see out A. Yay. Right? Awesome. Else if. Now, because I'm going to approach this from A minus, B plus, B minus, so on down, I can save a little bit of trouble here because I know I cannot get to this if this was true. So the only time I'm ever going to get to looking at this next if statement here is if this was false. Right? Because they're mutually exclusive. If this was true, nothing else here runs. Right? So now I can say, okay, if my score is greater than or equal to 89.5, we can see out A minus, right? Because we're still rounding here, right? So they're mutually exclusive. One and only one of these will run. So if this didn't run, I know this can't be true. So score being greater than or equal to 89.5 is really score is less than this and more than this, right? It sandwiches it in between just because I'm going in that order, in that sequence here. So these are mutually exclusive. First to match runs. And it is the first one. Whatever it matches first will be the one that runs. I can add these comments in anytime. Again, I'm biased against comments. I apologize. That's sort of the way most of the industry is going. We think comments are stupid for lots of reasons. Other people and other profs here will tell you you have to enter comments. Just smile and nod and do it because they give you a score, right? And that's okay. It's no biggie. When I was an undergrad, taking my first intro to programming class, had an assignment. Have I told you the story? Please, if I've told you a story before, just shut me up early. It's not worth hearing twice, I promise. They're not that interesting, okay? So I was in my first programming class, and my project, I forget what even the project was. It worked perfectly. And I got my score back, and I had gotten points off because I didn't have a comment that the prof wanted. And at that point in time, as an 18-year-old, I swore to myself, hey, if I ever get a chance to teach, if the program does what it's supposed to do, I will never take points off because it doesn't have comments. And I've kept that promise because I care if you can get the result. I don't care if you can put comments in, right? If we all cared enough to, I'm sure we could add comments. That's not, my goal is not that you are a good commenter, right? My goal at the end of this class is that you're a good coder, or, as good as you can get in one semester. Like, maybe let's not set the bar too high, okay? This is only 150. Yeah.
So, not having comments that are being able to comments that everyone's able to understand makes it beneficial to the coder, because then the company that we're working for needs that specific person to run that program. More valued by the company. Yeah.
So you're saying make your code hard to read so that you're the only one that understands it, so they can't fire you?
Necessary, easier.
So the school of thought that I subscribe to, and again, there's many, that's okay, is that if you need to add comments, your code could be better. You could use better variable names. You could use better method. We haven't talked about methods, so that doesn't make any sense yet. You could have other things that avoid the need for comments, right? So score, we could call it something else, right? We could add more information here. I had a really long variable name for one program I wrote because there was a really weird thing that happened, and the variable name was like 13 words because I explained what could happen. It was nonsense, but you can make your code more descriptive without adding comments. It is one school of thought, for sure. Now, the one caveat I'll say, if you're writing a public API or a library for someone else to use, comments that describe what your code does is super, super helpful and useful. That's a godsend, right? We want to do that. What we're doing here in class, what you're going to do basically your entire university career, you're not going to write a library that other people will ever use again in your life, right? We're not going to do anything that cool, sadly. We'll just be honest, right? The code we write is just exercises and toys and projects. Like nothing's going to live beyond when we get out of school, right? Maybe if you're lucky and you get joined on a research project and you do something really cool and interesting, maybe then someone can reuse that code. Most of the time it's throwaway, okay? So we don't care. We don't need that. So we'll just keep working our way down, right? So we just keep going, these mutually exclusive bits here. I'm just going to copy paste a bunch here because that's okay. And then we get what, like 83.5 then is a B. I'm sorry, we need a B plus, right? So that's 86.5, right? So like it's 87, 88, 89 is a B plus, I think. And then we can go down to 83.5 for regular B, and then down to 79.5 for a B minus. And you get the idea, right? Oh, that should be B, not A. Oops. We just keep working our way down, right? And just go. We could do more if we wanted, you know, dot. I don't really want to copy paste more, change a bunch more numbers. So for the sake of the exercise, right? I know that if I got to here, that score cannot be more than 86.5. If it was, this would never even get looked at, right? C++ will just take the first one that matches and skip the rest because they're mutually exclusive. They're chained together, okay? Now, the other way you can do it, you don't have to have a chain of if, else if, else if, else if, else ifs. You can just have an if. An if all by itself is perfectly fine. There's nothing that says you can't have an if there, right? You don't have to have an else. You don't have to have an else if. You can just say if this, do something. That's it. So we can see out, I don't know, enter your name here, and then we can have a string for name. We can see in name and say if my name is equal to Eric. Now with strings, I can never actually remember here. I should probably open the zyBooks and double check because this is not something that's in my head. Let's see. Do I have strings? String comparisons. That's what we wanted here. Yeah, okay, cool. So we can use equals, fantastic. Now, the caveat with strings, right, is that, remember we talked a little bit about Unicode, how letters are actually stored as numbers? Does that ring any bells? Letters get stored as numbers. A string is just a bunch of these numbers stuck together, so we have a bunch of characters. Now, remember, uppercase letters were different than lowercase letters in their numerical value, right? Because you need to represent them differently. So capital E Eric is not the same as lowercase e Eric, right? Because capital E is a different number, different letter than lowercase e. It's a different number, different letter. So you have to be careful here. So case matters with strings, right? Just a warning here. So if you entered Eric, what should we enter here? So I don't know, you win. If your name's Eric, you win. You get the prize. If your name's not Eric, nothing is going to happen here. There's no else, nothing else is going to happen. We're just going to continue on with our program here. We'll just keep going. So let's give it a try. Now, again, I'm going to run my program a lot. The idea here is that I'm going to make mistakes. I expect that I make mistakes, that I make typos, I make errors. So we call them bugs. Because way back when you had these punch card things, an actual physical bug could get stuck on one of those note cards, and then it would cause the program not to run because there was an actual bug in it. Someone has a note card with a bug on it somewhere in some museum somewhere. It's a fun story. But now we call them bugs when there's a logical error that we did the wrong thing logically. Now, C++ is going to do what I told it to do because it's stupid. Right? Computers are really dumb. They do exactly what we told it to do. And if you've ever written an English paper, how often do you write the wrong thing? Right? A lot. And then when you read it, you don't even see that you did it because you know what it's supposed to say. You don't see that you have the word and in there twice. So thankfully, Microsoft Word now is like, you probably didn't mean to say and twice. Right? Our Visual Studio is not that good yet. It's working on it. It's getting there. But it can't really tell, hey, I did something wrong with my range, or, this, I actually had an A in here twice, or whatever. Right? Like, it's not going to notice that. So what you want to do is you want to write a little bit of code and run it. Write a little bit of code and run it. Write a little bit of code and run it. Write a little bit of code and run it. It's an iterative process of developing small pieces at a time, rather than I'm going to sit down and code for 8 hours and then hit run one time at the end. You're in for a world of hurt if that happens. Okay. So what we want to do is not trust yourself because you probably screwed up somewhere. So what I want to do is I'm going to test it and make sure I can get an A, I can get an A minus, I can get a B plus, I can get a B minus, and so on and so on and so on. Right, we probably, actually, let's have we'll do the dot dot dots here, and then we'll have an else here for a C out F. Right, so if you didn't get a letter grade, you probably get an F eventually. So we're just going to skip all the C's and D's. We'll go right to an F. So if it doesn't match any of these above, the last else here doesn't look for anything. It just says, okay, if it's not one of the things above, it's sort of a default. If it didn't get me any of these, this must happen here. So let's try it. So let's give it a couple different letters here. So yeah, sunny and hot, sure. Percentage grade. So let's do like 95. That's an A. Great. And then Eric. I win. So that seemed to work. And we'll try it again. We'll give it some different values. So let's do 2. All right, let's try, how about 92? Should be an A minus. Yeah, we get A minus. Enter your name. How about John? Nothing happens. Sure. So we're going to run it and try these different values. So when you write your code, you should be able to say, if I give it this, this comes back out. It shouldn't be some sort of weird black box. Right? We know what's happening. We know for this input, this output happens. For this input, this output happens. If you can't do that, you don't understand the code well enough to even write it. Right? And that's the hard part of problem solving is, how do I go from this input, what has to happen to get this output? Kind of like math class, right? There's all sorts of formulas and different things you have to do to figure out, how do I take this and get an interesting output or a solved output? Right? You have to know the steps. Same with coding. So we're going to try that and test it, because we have no idea if it's going to do what it's supposed to do, because we screw up a lot, right? And that's okay. Making mistakes is fine. That's part of learning, right? Some famous person said it's only a mistake if you don't learn from it, right? I think somebody. No? Okay. Sure. All right, so we can do that. Let's see. We're jumping around a little bit here. Else branches, equal, branches, ranges, logical operators. Logical operators are really fun. So logical operators let me combine logic. So what we have inside of the set of parentheses here is a logical expression. So a logical expression is a fancy term for something that's true or false. Right? The only two options here are true or false. Because the if needs to know yes or no. Right? If it's true, it runs. If it's false, it doesn't run. That's the only thing we can give it. We can't give it anything other than a true or false expression. A Boolean expression is our fancy term, right? A Boolean expression, a logical expression. Boolean being yes or no, true or false, on or off, right? So we can give it this. Now, if we wanted to do more interesting checks here, so let's, I think there's another common one here. Let's say, see out, say, your age, end line, and see out, we need an int for age, and we can see in for age, and then we can see out, enter your gender, and we're just expecting M or F here. The insurance companies are not quite up to date with sorts of things, but essentially what we want to do here is model how much you're going to pay for car insurance. Men cost more when it comes to car insurance because men are stupid, right? It's a fact. Like, men will crash their car much more often. Young men specifically will crash their car, get in accidents way more often than women. There's all sorts of things we can get into. Go take the psychology class or some social science class. So you can learn about why brains are the way that they are. But as an insurance company, the insurance company's job is to make money, right? We can agree on that. If the insurance companies don't make money, they don't exist. So they're going to charge more money to people who cost them more money. So we're going to say, okay, if you're a male and you're under, I don't know, what is it, 28 or something, we're going to charge you more, right? If you're under 21, we'll charge you more anyway, male or female, because young drivers are also really high risk, right? But males are at risk longer. And then if you're over that age, male or female, we don't care at that point, then you will cost us less money. We'll charge you less, right? So just something silly like that, okay? So we can have a string for gender. We can see in gender. We can say, okay, so the first check, if you're under 21, we're just going to charge you a bunch of money anyway, regardless. So we can just quickly check, hey, if my age is less than 21, we'll see out your insurance costs, I don't know what, $200 a month? Is that a lot? $250? I'm just making up numbers here. Sure, okay. My son's about to get his license, and I'm terrified of what that's going to do to my insurance. If he doesn't have his own car, Like he's just listed as a secondary driver. Hopefully it doesn't go up quite as much because I'm not going to buy him his own car. He doesn't need his own car. Right? He can buy his own car if he wants. Right? All right. So we'll say, sure, $200 a month. That's fine. Then LSIF, right? If it's not less than 21, if your age is less than, what did I say, 28? So if you're up to 27 or so. Now, I like the word and here. And your gender is equal to male. I don't think that's going to work, is it? Can you really do that? Plus and keyword? Is that new? No way. Oh. Wow. This is new. Okay, this is very exciting. Usually, you'll see, that's super neat, that and is written as ampersand, ampersand, or ampersand? I don't know how you even pronounce this thing. Usually, you'll see it like this, and, right? Looks like we can use this keyword, the and English word, which is much nicer. That's very exciting. Wow. I've been doing it the hard way for so long. Goodness gracious. This is so much nicer. I get to do this in Python. It always makes me happy because Python is so much better than C++. But you're all stuck learning C++, I'm sorry. It's a very useful language, and tons of people still use it. It's just, it's hard. It's a hard first language. That's okay. We'll get through it. All right. So if you're less than 21, you cost $200 a month, no matter what. If you're not less than 21, if you're less than 28 and male, then we, oh goodness. That's probably why you're not supposed to have drinks in here. Even had a lid on. That's sad. Yeah, that's all right. We'll find some paper towel later. Oh, actually, I have some right here. I have napkins. Give me just 1 second. I'm sorry. I spilled it all over my lap. It's Monday, right? That was good coffee, too. Oh, thank you. It's right there. You're a hero. Thank you. Gonna need a little more. One. All right, almost there. It's not embarrassing at all. Don't worry. All right, at least it didn't land on my computer. That'd be worse.
Or like a $2,000 computer by tipping over a drink for a half a second, drink right in, and
Oh,
settle up, pop, and smoke.
that's so sad. Yeah, my little guy did that. He got into my office and poured a drink right onto my laptop, and it died. It's like, that sucks. But it wasn't mine. It was the company's. So they bought me a new one anyway. All right. Anyway, so now we're going to the next step here, right? So if you're male, you still cost a bunch of money. We'll say maybe a little bit less here. How about we do, say, how about 180? We'll give you a slight discount here. We still charge you a lot more, right? And then else, right? If it's not one of those, else here, we can say, hey, how about you just cost $100 a month or something, right? So a couple different cases here, but we're combining them with and, which is a logical operator. So you have ands and you have ors. You also have nots. We'll get to nots in a minute. So the way I always like to remember this, when you go to McDonald's and you order a quarter pounder with cheese because they're supposedly cooked fresh, if you know otherwise, don't tell me, because you don't want something that's been sitting in that warming platter for way longer than it should because they don't do health inspections often enough here. Right? They're supposed to cook it fresh for you, and they say, do you want fries with that? Your obvious answer should be no, because McDonald's fries are awful and nasty. No, you don't want fries with that, right? So that's easy, right? Because you say, no, I don't want the fries. I just want the burger. But if you go up and order, they say, hey, do you want a burger and fries? Your answer is still no, because you don't want the nasty fries. They're gross. that means you don't get your burger because they said, do you want a burger and fries? Do you want them together? And then you're sad because you don't get that burger. Actually, I haven't eaten them in a while. I've been vegetarian for a while, which is good for my cholesterol. So getting old is fun. You all have that to look forward to, all sorts of fun health stuff. But you would say no because you don't want that and this other thing, right? So and means both things have to be true, right? If they say, hey, do you want a burger and a milkshake? You say, yeah, I want the milkshake. I'm amazed your ice cream machine's working. But yeah, give me the milkshake. Sure. That's okay because both things are true. You want both of them. If you don't want either of them, if you're vegetarian like me, they say, do you want a burger and something? I'm always going to say no because I don't want the burger. It doesn't matter what the other thing is, right? Even if it's a delicious milkshake, I have to say no because I don't want to eat the burger. So with ands, both sides have to be true for the whole thing to be true, right? So true and true gives you a true result. False and true is false. True and false is false. False and false is false. That's a big mouthful there, right? But we can say with ands, so for and, right? We'll make a little table here, right? So true and true is equal to true. True and false is equal to false. False and true is equal to false. And false is equal to false, right? The only time you get true is when both sides are true, right? And I think that makes sense if you think about it. Just takes a little bit of getting used to. And again, you'll usually see the ampersands here. Apparently the and keyword has been around a lot longer than I realized, which is I'm super excited for because I don't know. It's one more character typing, but it's a lot easier to read, I feel like. All right. And then with ors, you have or also the pipe. So I think the or is much more exciting for you because that's the shift backslash. The button over the enter key is a pipe. Pipe for or. I didn't come up with it. Don't blame me. Right? With or, if either one of them is true, you say yes. Do you want a burger or fries? For me, that's still a no because I don't want either of them. Right? If neither are true, the whole thing's no. No. But hey, do you want a burger or a milkshake? Yes. Sure. Do you want a cookie or a burger? Yes. Right? Do you want a cookie and a milkshake? Yes. That's my favorite order. Cookie and milkshake. It's bad for my diabetes, but it's fun. It's delicious. So with or, if it's true or true, the whole thing is true. If it's true or false, the whole thing is true. If it's false, here we go. False or true, the whole thing is true. If it's false or false, the whole thing is false. So only if both of them are false do you get false with or, right? If either side, this or this is true, the whole thing is true. And then you also have nots here, not or the exclamation mark for not. The exclamation mark is fun. So you'll see this one a lot here. So you have not true is false, and not false is true, right? It's the opposite. So if it's not true, it's got to be false. If it's not false, it's got to be true. We only have one or the other. So we can combine any of these logical operators here. These are our logical operators, right? With ands, ors, nots. Okay. Now I should have showed you because I did way too much more work than I need to. If you do /* and then // you get a comment block. And it says everything in here is going to be commented out. You don't need to do individual lines here, right? Which is kind of nice. So that would save a little bit of typing here. If I did it like that, does that look nice? It's probably a little nicer here. Okay, it's just telling C++, hey, ignore everything until you get to the end of the next one here. And I should probably, let's untab that one maybe. These are our logical operators. Okay, so we can mix relational operators and logical operators. We did that here. If you're less than 28 and your gender is male, you get charged more money for car insurance. Good news, because you cost more money, right? So we could combine it. Now, you can combine as many of these things as you want here. If this and this and this and this and this or this and this or this and this, not this, go nuts. Now, at some point, it's going to look like garbage because no one will be able to follow it, right? It's just too long here. We can't understand how all that works. And now the other fun thing is there's an order of precedence here when you do ands and ors. And I never remember which one is which here. I think it tells us, does it tell us precedence? I think it's in this one here. Branching errors, correct operators. No, okay, shoot. Where is it here? Oh, we'll just Google it here. C++, logical operator precedence. Let's see. That's not helpful. That's still not helpful. That was not a good answer. How about this one? Not and or from highest to lowest. So the not makes a lot of sense because if it's attached to something that's a unary operator, or fun math terms, if you like that, like a negative number is a negative number. Like that's the negative sign's like a unary operator. It makes that number negative because it's touching it. Not's the same way. It's touching it, it just flips it immediately. Then we do ands first and then ors. I don't know who decided, but someone had to pick somewhere, right? So if ands happen first and then ors, right? We have to go for it. We'll figure it out. So if we wanted to, let's do another case here. So let's look at whether or not you can get a mortgage for a house, right? So the mortgage industry is awfully automated now, and no one really does real underwriting anymore. Anyway, we just throw it into a computer algorithm and it spits out yes or no. And then you talk to your bank and they're like, oh, sorry, the computer said no. Like, come on, like, can you do anything? No, the computer said no. But whatever. So we got to beat the computer here. So we'll say if you have 20% down payment, someone's going to give you a mortgage because you gave them a bunch of money, and if you stop paying, they'll just take the house back. They don't lose, right? Because they'll get the 20% down that you put, they just get right back. So 20% down is fantastic. If you don't have 20% to put down, now we're going to start looking at, hey, what's your credit score? Sure, we can do something like that and say, okay, do we think you're good for paying the payments here until we've made enough money that we can take your house and not lose money on it if you stop paying? Right? Banks exist to make money. Right? This is how society works. So I'm going to say, see out, how much does the house you want to buy cost? And then we'll get a, how about, that's probably an integer. You probably don't have decimal places when you're buying a house for, $300,000. You probably don't care about the pennies. So we'll buy a house cost here, and we can see in for house cost. Okay, and then we can see out how much money you have for down payment. Down payment. And then we can have probably another integer here, right? Down payment. You can see in the down payment. Okay, so our first check then, we can say, hey, if this is 20% or more, you're good to get a mortgage, right? So we can do that arithmetic real quick. We can say, okay, if the down payment divided by the house cost is greater than or equal to 0.2, right? I think that's straightforward arithmetic, I hope. I screw things up a lot, so yell at me if I'm doing it wrong. Here, you can see out, you get a mortgage. All right, there we go. And 15-year mortgages are generally the ideal here. 30 costs less, but you're paying way more because you're paying 15 more years at a lower rate. You'll typically pay, depending on the interest rate, like 2 to 3 times what the house cost with a 30-year mortgage. With a 15-year mortgage, it's like 50% more than the house cost and interest. Again, depending on interest rates, but sure. All right, so that's our first arithmetic. If it's not that, then all right, well, now we need to start looking at some other values here. So now we can say, okay, see out, we probably need some more information. We can do that after, right? Why not? So we'll say, okay, how about an else here? So, and you can put lots of code inside an else. So if it's not good enough here, that down payment isn't large enough to qualify, enter your credit score. Sure, why not? It's a little bit long, but that's okay. And again, this is probably an integer here. So for credit score, we'll say, and then we can see in the credit score. Okay, cool. So we've got that. Now we can check. Okay, so how about if the down payment divided by the house cost is greater than or equal to 0.1? If you got 10% or more, right? And your credit score is greater than, I don't know, let's say 700 or something. I'm making up numbers here. I have no idea. Right? I'm not a banker. Right? If these two things are true, then we can see out you get a mortgage. mortgage. Wait, I think I spelled that right. Sure. If that's not enough, right? Okay, well, they credit score wasn't great. This was pretty good, and they had 10% here. How about we'll say else if the down payment is divided by the house cost is greater than or equal to 0.05, it's 5%, and, oh, sorry, we should use and here. Why not? So these ampersands. And your credit score is greater than, how about we'll do like 750. So if you have 10% with 700 or better, you get it. If you have, else if, sorry, your 5% down payment and a better credit score, you can get a mortgage. Sure. Right? Else, no mortgage for you. Okay. Now, this code has a lot of duplicates here. This is totally functional, right? And this will definitely work here, right? We'll check this first one, and we should run it and see if it works, right? It's probably before I commit to anything here. Let's do that. So give it some values here. Eric, there we go. All right, age. Oh, this was for the insurance, right? So I'm 36, so I'm going to get cheap insurance anyway. All right, so the house we want to buy. So if we want to buy a $200,000 house, and we have 20% to put down, that's $40,000, right? You got that in your back pocket, right? Easy. No, I'm sorry. Is that too soon? Does that mean? Sorry. Uh-oh. Down payment isn't large enough to qualify. Let's see. Huh. Did I do the math wrong? Did I miss a zero? 40,000 for 200,000? That's interesting. I really expected that to come out working right. Huh. Oh. Yeah. Yep. So let's do this. I'm dividing an integer by an integer. Hang on. So let's do this. This is fun. So we'll just see out down payment divided by house cost. Here. Let's see what we get. I think it's giving me something I don't expect. That's unfortunate. Dividing integers can get weird. One. Okay, so 200,000. 40,000, yes. I did a dumb thing. I took an integer, divided by an integer, I got an integer result. C++ is lovely sometimes. I think we ran into this like the very first day or second day of class. Does this ring any bells? It's been a little while. If you take an integer and divide by an integer, you get an integer result, usually. Sometimes it works. It's a little weird. So I got 0 because there's no holes here. So the easy fix for that is just make one of these things a double. That's the easy fix. You can do that static casting. If you did that in the Zybook, it's good for you. You actually went and saw that. We could cast them as a double just for this arithmetic here. That's generally a little harder here. So I'm just going to say, we'll call this one a double here. Now, if either one of your operands is a double, you'll get a double result. Because C++ is like, oh, one of the two things is a double, I'll give you a double back, yeah? So I'm going to make one of them a double, so C++ says, oh, one of the two things is a double, you don't want an integer answer. You want a double answer. Yep. So if one or more of them is a double, here, so this is, you divide integer by integer, you get integer results. Does that make sense? Okay. Which most of the time, right, if you're adding integers or subtracting integers or multiplying integers, you want an integer result. It's just with division that we really care about the decimal place. So most of the time it's helpful, right? We don't need to use all that extra space, so why bother? All right, so let's try. And this is why we run our programs, right? Mistakes will happen. This is I totally meant to do this. This is perfect. All right, let's try that again. 1. All right, 200,000, 40,000. Hey, there we go. We get the mortgage, 15-year mortgage. Now, all of this works, probably, right? We could try it and see all the other ones. But it's really messy. I mean, it sort of flows. We can kind of understand this, and then else this. That's all perfectly fine here, right? But wouldn't it be nice if you had two different ways to get a mortgage? We want to combine those. That's where OR comes in handy, right? I can say this or this, right? So I don't need to have two different actions here. I can just now say, or, I'm going to take all of this here and move it up, right? Great. So if it's this one or it's this one, you get the mortgage, right? And because our order of operations with ands means this gets evaluated, we and them together. Now I have a true or false, right? This gets evaluated, and this gets evaluated. I and them together, I get a true or false. Then I have true or false, right? So the or combines them. Now, I'm going to recommend, just because it's maybe risky or easy for us to forget the order of operations, if you want something to happen first, just add the parentheses, right? Adding redundant parentheses never hurts anything, right? You don't need the parentheses here, but now you can definitely tell this whole thing or this other whole thing. Because otherwise, what if if we didn't realize we got this or together? Now, it wouldn't do that because we know ands happen first, but if you don't remember that, because who remembers the order of precedence for logical operators, you have to go Google that, and then the first Google search result isn't even useful. That's really depressing. Sure. So put the parentheses in, right? Force the order to happen the way you want, just to be explicit, right? The code's for people. We write the code because we want to be able to see it and understand it here. So adding the parentheses helps me see, okay, this whole chunk or this whole chunk. My life is easier now, okay? Now, if we wanted, we could also combine it with this one up above, but then we'd also have to ask for their credit score. So we could say, hey, how much does it cost? What's your down payment? And what's your credit score? And then we can have three different conditions. Okay, you have a 20% down payment, or you have a 10% down payment in this score, you have a 5% down payment in this score. This or this or this will all qualify you. You can do that, right? This is just a preference here for what do you want to have. Do you want the prompt first? Do you want the prompt second? Do you care about the prompt? Do we not care about the prompt? That's just style, right? It'll accomplish the same goal here. But now we're just figuring out our style. Now, the more code you put inside of blocks, like the further stuff gets tabbed. I don't know if you notice, right? Like we're in one tab, in two tabs, in three tabs now for this level. It's starting to get a little far here. So ideally, we can avoid a lot of these nested if-else stuff, like putting ifs inside of ifs inside of ifs inside of ifs. Totally works. But if you can use some logical operators to not have to nest as far, generally that's preferred. Because it gets a little messy as you're like 5, 6, 7, 8 indents in, then like you can only see a couple bits of code before you have to scroll left and right. Remember, scrolling left and right is a bad thing. I'm going to try and avoid that. I'm zoomed in a lot, so I have it a little bit left and right, but generally at a decent font when you're not trying to show up on a screen here that everyone can read, you'll be perfectly fine. Okay. So does that make sense? We can put these inside of the other ones here. All right, you folks are doing great. Let's see how we're doing on content. So else, branches, ranges, logical operators, gaps, multiple features with branches. I think this is what we just did with the ands and ors, right? Let's see. This is really weird. If you just have ifs, right, with no elses, they're not mutually exclusive. So more than one of these can run. So at this point, if you're 36 like I am, all of these will run except the first one. Because it's not true, but I'm more than 15, I'm more than 17, I'm more than 24, I'm more than 34. All of those will run for me because we didn't make them mutually exclusive. That's okay. It's totally up to what you want to accomplish. They don't have to be in a chain, right? Sure, that's perfectly fine. Like all of these apply. I can drive, I can vote, I can rent a car, and I can run for president, right? All of those apply. Right? That's okay. So multiple features is fine. I think that's good. Word evaluation, great. Yeah, we'll save switches for later. No worries. We did string a little bit, and then we'll do some more string and stuff later. Yeah, okay. So I think we got about as far as we needed to with what we have now. If we think back to the project, right? We go back to project 0. We've got everything we need. Right? The goal with project 0 is that we're going to ask them what are they serving, right? Are you serving pizza? Are you serving sandwiches? Are you serving drinks? So if you like the numbers menu, say, okay, enter 1 for pizza, 2 for sandwiches, 3 for drinks. If you want to just compare strings, like we did with, hey, is your name Eric? Where'd that one go here? It's in here somewhere, right? Is the thing you're serving equal pizza? Perfectly fine. You can do that as well. Yeah. I'm sorry? getting rid of, like if I wanted to see out my name, so you win, and then add a name, like the name variable, which is a string, should be perfectly fine. Let me double check. I don't think there's anything special you need. Enter your name, so Eric. You and Eric. So if you're CNing multiple values, like if I want to type Eric Chinesky, I have to do the get line thing, right? Because yeah, spaces will screw things up. You got to be careful with that. So if you're doing get line, it will get the entire line, assign it there. But if you CN, it actually leaves like the enter key around. It gets kind of messy. Like if you mix and match those things. Yeah, we can do some more practice with that, but I can take a look at your specific example if you want. All right. So we can say, okay, if they entered this, then we do this block. If they entered this, we do this block. If they entered this, we do this block. Does that make sense? So, and they're probably mutually exclusive, right? And if it's not one of those things, we can tell them, I can't help you. That's perfectly fine, right? We can have that default else. And I did forget one thing here, I'm sorry. We also want to ask them for their name and use their name in the following prompts, right? So it's nice when the computer pretends to be personal here, so we're going to do that as well, right? And then I can build out that rubric for you that I forgot. So we build out the rubric here. So this is for project 0. So when you turn it in, you're going to assess yourself using this rubric. You'll tell me you got the points, you didn't get the points, or maybe you got partial points, right? Perfectly fine here. So they're going to be 2 points each. So the first one here is prompts for name and uses name for 2 points. And so calculates, asks for type of, is it food? I don't know. I think we also said beverages, but is that food/beverage? And what was it? And sort of type of food and beverage, and I don't know, does appropriate. That's a terrible sentence there. That's okay. And then calculates for pizza party correctly. Calculates for, I forget, what is the other one? It was pizza or sandwiches. Sandwiches correctly. And then we had drinks. Calculates for drinks. For drinks correctly. Goodness, those should all be 2. Yeah. All right, so that should be 10 points. Right? Does that make sense? So having the branches here, like, so if you just do a pizza party, you can get 4 points, right? For asking their name and doing a pizza party. You can get 4 out of 10. That's perfectly fine if you want partial points, right? I think you can get all of them here, but that's the idea with this. Does that make sense? All right, so we're gonna do that. And then this idea of having screenshots in your README, right? When you run your program here, let's hit run, and we'll say, okay, this is rainy. Let's do grade of 95. Your name is Eric, yada, yada, yada. I'm gonna grab a screenshot. Now in Windows, you can hold the Windows key, Shift, and S. I should put that down. I should mark that down here. Let's do that. And a screenshot. And Windows key plus Shift plus S. On Mac, I'm sure it's something similar, probably just a print screen key. Print screen works, but you get more usually. So Windows Shift S gives you the snipping tool, and you can say, I just want to grab this here. You can grab that. And then when you come to your repository, I'll actually go commit this real quick first. So here's the 3 examples, commit and push. You can go to your README file and you can say, hey, I want to edit, right? I did this once already before. So you can add another screenshot and just hit paste with that on your clipboard, and it will actually upload the image for you, which is super cool. Give you this link here. Don't worry about it. It's a markdown link. It's fine. And now we've got, in a second here, I think it just has to refresh. We'll get the other screenshot. So you can add in the screenshots to say, okay, here's where it did a pizza party. Here's where it did a sandwich party. Here's where it did a beverages only party. Right? So 3 different screenshots to show each of those things work if you get points for all of them, right? And then, hey, I got 2 points here, I got 2 points here. Now, you can't use the rubric, which is really obnoxious in Canvas. Like, I can use the rubric when I'm grading. I say check, 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 check. It's not interactive for you. You just see the rubric here. So you just have to tell me, okay, 2 points for this, 2 points for this, or copy paste, or take a screenshot of this if you like doing screenshots. And then in the snipping tool, which is really fun, maybe. Come on, where's my snipping tool? Seriously? Snip. Come on. It didn't do it. That's fine. Usually it pops up here. You can like mark things on the screen. That's fine. That's okay. However you want to tell me, 2 points for each is fine. Right? If you ask for the pizza party, but it doesn't calculate correctly because you didn't do all your rounding stuff, you can still get partial points. Give yourself 1 out of 2. Right? That's perfectly fine. Lots of different ways to do the rounding. Right? You're welcome to discuss it. Again, you can talk about the project in English. I'm happy with that. You can't share code, right? So if you're taking notes down in what you're going to do in code, we've gone too far, right? So if you come up with a great idea for rounding, tell someone. That's okay. Don't give them the code, but I mean, it's like 1 line. It's no big deal here to do that, but tell them. That's okay, right? That the hard part is not how do you round numbers. That's not a big mystery problem that you all need to solve yourselves here, right? That's something you can go figure out, right? Does that make sense? Okay, cool. Any other questions, thoughts, concerns? We've got lab later today. Labs will be due the week after they're assigned so that you've got time. The goal is you walk out of lab done if you want to stay the whole time, right? If you show up and you're tired, you get tired of it, you get bored of it, whatever, you're just not having a good time, go home. You don't have to finish it before you leave. That's okay, right? Now, if you don't come and you have lots of questions about lab, I'm going to give you funny looks because the lab time is the time I have set aside and you have set aside for me to answer those questions. Right? Now, if you have to miss one and then you've got questions, that's okay. 1 I'll give you. If you just never come to lab and you always ask me questions about lab, I'll start to get upset. Right? Because the lab time is when we have for that. Right? But if you don't come to lab, that's okay. You guys are all adults. You get to manage your schedule. You figure things out for yourselves. You can go get the work done after. As long as you get it in on time, I don't care. Right? But that's the time we have set aside where I can walk around the room and answer questions and help look over your shoulder. We can be at the same computer and that sort of thing. Is that reasonable? Okay. So I know it goes late. So don't feel like you have to stay till 5:45 every single Monday. I know that gets really late. Yeah, question?
What chapters is lab going to be on today?
Mostly 2. We'll do maybe a quick branch for 3. Nothing super crazy, but I want to make sure you can do everything that you need for the project. So should be able to get that done with like a quick here if this is true, right? Not anything fancy. Okay. Yeah. Other questions, thoughts, concerns? We good? Yeah. No. So we're in HPEC 1190. That's the engineering complex. Heinz Prechter, I think. He probably gave a bunch of money to the school. I don't know. I don't know the guy. There's a plaque with his name on it and like a blurb if you're curious. So, yeah, so we'll meet over there 4 o'clock or so. Again, stay till you're done. Stay for a minute and leave. Don't come at all. Totally up to you. I'll let you figure that out yourselves. Yeah. HPEC or just EC 1190. Yep. All right, awesome. Thanks, folks.